Hello guys, welcome to my channel. We have made this video for anyone who is looking to implement TLS in their solutions or the learners who wants to brush up their concepts or most importantly security consultants. Is TLS the strongest security measure? Well, TLS protects communication channels by providing state-of-the-art protection against eavesdropping and tampering. The security of TLS relies on both cryptographic strength and implementation hygiene. However, the reality of this will also be explored in this video. So topics which we will try to address are how TLS works, what are its types, and how safe it really is. Okay, so what is TLS? Transport Layer Security. TLS is a cryptographic protocol that ensures secure communication between two systems over the internet. TLS achieves this by using encryption algorithms, digital certificates, and a process known as the TLS handshake. In a typical client-server model, TLS is used in from protecting websites via HTTPS to encrypting email transmissions and API communications. Mostly, the open source toolsets like OpenSSL are used on web servers like NGINX or Apache. Cloud providers also integrate this in various services like load balancers. Before we start handshake process, please get yourself familiar with the general terms and concepts which you can see on the screen, which are very critical to understand TLS. Okay, so let's talk about the 7 crucial steps in the TLS handshake 1. Client hello. The client initiates the handshake by sending a client hello message to the server. It includes the client's supported TLS versions, cipher suites, and a randomly generated value known as the client random. 2. Server hello. The server responds with a server hello, choosing the protocol version, cipher suite, and sending its own server random value. 3. Certificate exchange. The server sends its digital certificate, which contains its public key and is signed by a trusted certificate authority, CA. The client verifies this certificate to ensure authenticity and trust. 4. Premaster secret generation. The client generates a premaster secret, encrypts it using the server's public key from the certificate, and sends it to the server. Only the server can decrypt it using its private key. 5. Master secret derivation. Both the client and server compute a master secret from the pre-master secret and the two random values exchanged earlier. This master secret forms the foundation for session key derivation. 6. Session key generation. From the master secret, both sides derive symmetric session keys for encryption and MAC keys for integrity verification. These are identical on both ends. 7. Encryption and decryption. Once keys are established, secure communication begins. Data is encrypted with session keys before transmission and decrypted upon receipt, guaranteeing confidentiality and integrity. Types of TLS 1. One-way TLS, server authentication. This is the most common form of TLS used in HTTPS. The client verifies the server's certificate, ensuring it's communicating with the genuine server. The server does not verify the client's identity. 2. Mutual TLS, two-way authentication. In mutual TLS, MTLS, both the client and server exchange and verify certificates. This two-way validation enhances trust, often used in secure APIs and enterprise environments. 3. TLS versions. TLS has evolved with time to patch vulnerabilities and adopt stronger cryptography from version 1.0 to 1.1, 1.2, and finally to 1.3. TLS 1.3 is currently the safest and most efficient version in use. TLS versions basically tells us about the cryptography being used, for example, cipher suites. So now let's talk about the topic, is TLS really safe? So Remember the certificate exchange step in Handshake. The server sends its digital certificate, which contains its public key and is signed by a trusted certificate authority CA. The client verifies this certificate to ensure authenticity and trust. Yes, so the client verifies the certificate based on pre-installed list of certificate roots signed by the renowned CA of the world. These root certificates are available in almost all the public internet devices like phones, laptops, TV, etc. If anyone is able to put their own certificate in these trusted list of certificates, then they can simply sniff your TLS connection. And guess what? Your server would never know of that. Common examples are rooted Android devices or jailbroken iOS devices. The trust factor is gone, the safety of encryption is gone. There are many tools available nowadays which support this sniffing, so simply relying on TLS is not a very wise choice. Instead, please focus on your endpoints also. Do not just rely on default measures provided by your device or server like trust stores, because they can be easily compromised. Thank you for watching this video. Do give your feedback in the comment section. Happy learning. Stay tuned for many more amazing tech videos.